Here we have tangents to a circle which meet at a point are equal in length. So that means if I have a circle and tangents that meet at a point, so if I call this A and that point B, they meet at C, I want to prove that these two are equal. Now, if I have a tangent to a circle, that means it makes 90 degrees with the radius. And again here, 90 degrees with the radius. Now notice if I cut it like this, I'll have a right angle triangle on this side and a right angle triangle on this side. Now how can we prove that this is equal to that? Well, because they're right angle triangles, we can use Pythag. So I can use a squared plus b squared is equal to c squared. If I label this long line x, and that's opposite 90 degrees, so that's your hypotenuse, and I want to find this line, and this is r. To find, let's just say this line is a. To find a, I'm going to do c squared minus b squared and square root it. So here a is equal to x squared minus r squared, and I square root it. I'll do the same thing here if I label this b. So the hypotenuse is x squared minus r squared, it's radius, and I square root it. Notice how these two are equal. So I've proved it. These two are equal, and therefore tangents to a circle which meet at a point are equal in length. The next one, the alternate segment theorem, and it says angle between a tangent and a chord is equal to the angle at the circumference in the alternate segment. So that means if I have a circle and a tangent, and say I have a chord like this and another chord like that to form a triangle, this angle here, if I label that x, then this is the same as it, the alternate angle, and this is also x. If I have y, the alternate angle here, that would be y. Now how can we prove this? If I have a circle and a tangent to a circle, so if I have a tangent to a circle, that means diameter would make 90 degrees with this circle. And if this diameter was to meet at a point, that point is also 90 degrees. So that's another theorem, another circle theorem. Wherever the diameter meets on a semicircle, this is 90 degrees. So already I have a similar scenario to this. X is equal to x. So that's 90 and that's 90. Now if this is 90 and that's 90, I label this x. To find this angle here, using angles in a triangle are equal to 180. So that angle there is going to equal 180, take away 90, take away x, which is equal to 90 take away x. So that's that angle there. Now if I wanted to find this angle over here, so because this is on a straight line and straight line adds up to 180, I could do 180, take away this 90 degrees, take away that angle there, so I'll use brackets. That would give me 180, take away 90, take away 90, plus x, so I'm just expanding this out, which is equal to x. So that angle is x. I've proved that this alternate angle is equal. So that's what the alternate segment theorem is, and that's how you prove it.